Welcome students. Today we will solve first problem on the topic kinematics of particles. So let us start today's lecture. So we are given one question over here. Let us read that question first. The position of a particle which moves along a straight line is defined by this relation, where x is expressed in feet and t in seconds. Determine A part, the time at which the velocity will be 0. B part, the position and distance traveled by the particle at that time. C part, the acceleration of the particle at that time. And D part is the distance traveled by the particle from time 4 seconds to time 6 seconds. So we are given one equation over here, and it is related to the position of a particle which is moving along a straight line. And in this equation we are given x as the distance, which is expressed in terms of feet, and t is the time in seconds. So let us solve its A part first. He says determine the time at which velocity will be 0. So we have to find at what time the velocity of the particle will be 0. So we are given the equation of position of the particle, which is in terms of time. So we are given this equation, x is equal to t cube minus 6t square minus 15t plus 40. And we have to find in A part that at what time the velocity will be 0. So in order to find that time, first of all we need equation of velocity. And we know if we are given equation of the position of the particle, then we can find equation of velocity of the particle by taking the derivative of this equation. So v will be equal to dx by dt. So we will take the derivative with respect to time. So it will be equal to 3t square minus 12t minus 15. So equation of velocity will be equal to 3t square minus 12t minus 15. So we got equation of velocity. So we have to find at what time this velocity will be 0. So we will put v equal to 0 in this equation. Right now we have v equal to 3t square minus 12t minus 15. So we'll put v equal to 0 and we will get a quadratic equation here. So this is 3t square minus 12t minus 15 equal to 0. So this is a quadratic equation in terms of t, and in this equation we have a equal to 3 and value of b is minus 12 and value of c is equal to minus 15, because quadratic equation is written in terms of ax square plus bx plus c equal to 0. So a over here is 3, b is minus 12 and c is minus 15. So the formula for quadratic equation is minus b plus minus b square minus 4ac. We take the under root of this part and we divide it by 2a. Now let us put the values of these in this particular formula and we will get value of time, and we will get two values of time, and of course we will consider the positive value. So when we will put these values in this formula, we will get time equal to 5 seconds. So we have got answer of the first part, that after 5 seconds the velocity of the particle will be 0. Now let us move on to the next part, that is B part of this numerical. In the B part we have to determine the position and distance traveled by the particle at that time. At that time means at time equal to 5 seconds. So let us see how we can solve B part. So you have to find the position at t equal to 5 seconds. So we know the equation of position is this only, which is given in the question to us. So if we want to find the position of particle at time t equal to 5 seconds, so we have to put value of t equal to 5 in this equation. So position at t equal to 5 will be equal to x5. Replace t by 5 in this equation. So we'll get 5 cube minus 6 into 5 square minus 15 into 5 plus 40. So when we will calculate this equation, we will get x5 equal to minus 60 feet, because in the question the unit of x is given to us as feet. So x5, that is the position of the particle at time equal to 5 seconds, is minus 60 feet. So we have found the first answer of B part, that is position of the particle at that time, that is t equal to 5. Now we have to find distance traveled by the particle at that time, means what distance particle will travel by this time, that is t equal to 5 seconds. Now it means we have to first see the position of the particle from t equal to 0 to t equal to 5 seconds, because he is asking us to find the distance traveled by the particle at that time. So we have to see the position of particle at different time intervals. So we'll first find position of particle at time t equal to 0. We will try to find out that when time was equal to 0, then at that time what was the position of the particle. So for that we have to make use of this equation. So what we will do, we will put value of t equal to 0 in this equation. So that equation or that value will give us the position of the particle at time t equal to 0. So we have replaced t by 0 and we have got that at time t equal to 0, particle was at 40 feet from the origin. And after this we will see that what was the position of particle after 1 second, that is time equal to 1 second. So again we will replace value of t in this equation, but this time we will replace that value by 1 second. So from that equation we will get the position of particle x1 after 1 second, and we have found that position of particle after 1 second is at 20 feet from origin. Similarly we will find position of particle at time equal to 2, means after 2 seconds. So this is equal to x2, so we have replaced t with 2 and we got minus 6 feet, means after time equal to 2 seconds particle was at 6 feet from origin. Then we will see position of particle at t equal to 3 seconds. So now we will replace t with 3 and we will get this equation, and this equation will give us the value of the position of the particle at time equal to 3 seconds. So this is equal to minus 32 feet. So it means after t equal to 3 seconds particle was at minus 32 feet from the origin. Similarly we will find the position of particle at time equal to 4 seconds. So for that we have to put the value of t as 4 and we will get the position of the particle, that is x4, at time t equal to 4 seconds, and from this equation we will get that value as minus 52 feet. Now we have to find the distance traveled by the particle at that time. What time? At t equal to 5 seconds. It means we need value of x5 also. We need the position of particle at time equal to 5 seconds. So that we have already calculated in the first part of B part. We have found that at time t equal to 5 the position of the particle is at minus 60 feet from the origin. So we have got positions of the particle at these intervals at t equal to 0, t equal to 1, t equal to 2, 3, 4 and 5. Now it will be easy for us to find the distance traveled by the particle at t equal to 5 seconds. So for that, what we need to do, we need to draw a line, and we will mark origin on that line. Now we'll see, or we will label these positions on this scale. So at t equal to 0, particle was at 40 feet from origin. So towards left of origin is the negative side, towards right of origin is positive side. So 40 feet means positive side. It means from origin we have to move 40 feet towards right. So this was the position of the particle at time t equal to 0. But at time t equal to 1 second, its position was at 20 feet. So let us label that also. So position is at 20 feet at time t equal to 1 seconds. At time t equal to 2 seconds, its position was minus 6 feet. It means towards left of 0. So let us label that value also, minus 6 on the left of 0. Then at time t equal to 3, position was at minus 32 feet. So from 0, measure 32 towards left side. This was the position at time t equal to 3. Then at time t equal to 4 seconds, position was at minus 52, means from origin minus 52. It means after x equal to 0, the particle is traveling towards left only. So at time equal to 5 seconds, the position of the particle was at minus 60 feet from the origin. So from origin we will measure minus 60. Now we will find the distance. Now you see at t equal to 0, particle was at 40 and it is moving on one side only. At t equal to 1 it was at 20, then at minus 6, at minus 32, minus 52, minus 60. So it means particle was moving towards one side only, that is towards left. So distance traveled will be equal to 40. Particle has covered 40 feet first, then particle has covered 60 feet on the left of the origin. So total distance traveled by the particle is 100 feet at t equal to 5 seconds. So we have got answer for B part also. Now let us see what we have to find in C part. In C part he says determine the acceleration of the particle at that time. That time means t equal to 5 seconds. So in C part we have to find acceleration at time t equal to 5. That means we need equation of acceleration first. And in the A part we found equation of velocity, and that equation was equal to v equal to 3t square minus 12t minus 15. And from this equation we can get the equation of acceleration. For that what we need to do, we have to take the derivative of this equation with respect to time. So we will say acceleration A is equal to dv by dt. So let us take the derivative of this. That will be equal to 6t minus 12. So that will be equation of acceleration for the particle. And we are asked to find acceleration of the particle at that time, means at time t equal to 5. So what we will do, we will put value of t as 5 in that equation. So that will be called as acceleration of the particle at time t equal to 5 seconds. So that will be equal to 18 meter per second square. So we have got answer for C part as well. Now we will see what we have to find in D part. So in D part we have to find, determine the distance traveled by the particle from t equal to 4 seconds to t equal to 6 seconds. Again we have to find the distance, but now we have to find distance from 4 seconds to 6 seconds. Earlier we located the position of the particle up to time equal to 5 seconds. But now we have to locate up to 6 seconds, but the starting point is 4 seconds. It means for D part, first of all, we need the equation of position of the particle, which is given to us in the numerical. So first of all, we will find the position of the particle at time equal to 4 seconds. And this we have already calculated actually in the B part. So when you will put the value of t equal to 4 in this equation, you will get the position of the particle as minus 52 feet. And in the B part, we have calculated up to t equal to 5 seconds. And it means when we will put the value of t equal to 5 in this particular equation, you will get position of the particle at time equal to 5 seconds, and that will be equal to minus 60 feet. So these two values we have already calculated in the B part. But in this case, in this D part, we have to find the position of particle at time equal to 6 seconds also. So for that, we have to put the value of t in this equation. So we will get x6, which is the position of the particle at time equal to 6 seconds. So when you will put this value in this equation, you will get x6 as minus 50 feet. So we have located the position of the particle at time equal to 4 seconds, time equal to 5 seconds, and time equal to 6 seconds. So now we have to find the distance traveled between that time. So for that, let us draw a scale over here. So this is a line, and let us locate the origin on that line. And now let us locate the position of the particle at time equal to 4 seconds. So particle was at minus 52 feet, means on the left of the zero. Let us mark minus 52, and then the particle was at minus 60 feet at time equal to 5, minus 60. Then the particle was at minus 50 at time equal to 6 seconds. So it means now particle started moving towards right. So particle was at minus 50. Now let us calculate the distance traveled. So at time equal to 4 seconds, particle was at minus 52. Then particle has traveled 8 feet towards left. Then from that, particle traveled 10 feet towards right, means up to this minus 50 value. It means distance traveled is 8 plus 10 equal to 15 feet. So we have got answer for D part as well. And I hope this numerical is clear to you. Thank you very much.